So, okay. So, good morning, class.
Good morning.
Morning.
Good morning, sir.
Thank you
Good
very,
morning.
thank you very much for attending this class. Uh, First of all, I'd like us to take a register. If I call your name, just present yourself by showing me your palm. Okay. So, Ernest, by show of a hand.
Present.
Bogo, Kevin. Kevin Bogo. Okay, I can see Elisha Leting. Okay, okay. Dennis Wangila and Daniel Kiliswa.
Present.
Okay.
Present.
So
Present.
thank you very much. So for our lesson today, our learning outcome is that by the end of this lesson, we are going to be able to derive the power equation developed by a single acting piston pump with ease. Okay. So before I begin, I want us to look at some of the parts of a single acting piston pump, and I'm going to share the screen. So very briefly, so you can see from this screen that you have a cylinder, you have a suction pipe, suction valve here, a delivery valve, a piston, this piston here, a connecting rod, and there's a prime mover here. Okay, so briefly, I'm going to share a video that is going to show us how a single acting piston pump works. Then we're going to derive the power equation from the same. So, so I'm going to play the video in a moment. Okay, all right. Okay, now. Okay, I hope the video was educative. Okay, have you all been able to see the video? Daniel Kiliswa?
Yes, I've been able to see the video on single reciprocating pump.
Okay, very well. Now, let us now go ahead and derive the power equation developed by a single acting piston pump. Okay, so from a basic principle of physics, uh, what is work and how can we define work? If someone is lifting a 10 kg stone on their head and they are not moving, will we be saying that they are doing any work? Elisha, Elisha Latin? Okay, Ernest Kipletich, yes?
Yes, I can hear.
So if you are lifting a 10 kg and you're not moving any distance, will you be doing any work?
No.
No. So work basically is defined by the distance moved by a force. Okay. So
Yeah.
for this class, we are going to define work and power at the same time. So power is the rate of doing work. So work is a displacement moved by a certain force through a certain distance. So in this, for the power developed in the reciprocating pump, then we are going to lift a certain volume of water through a given height. And our volume is given by pi base area times height for a cylinder. So if you can get the volume, then we can get the mass, and from the mass, then we can calculate the weight of the fluid that is being lifted. So um, from this uh, diagram here, here is the cylinder, and now the base area is the area of the piston, and the height is the length of the cylinder. So the volume of the water is the volume that is being occupied inside the cylinder. Now, from here, then we find that in order to get the mass, then we have to calculate the volume from the density of the water. So if you multiply the density times volume, you get the mass. And the weight now is given by mass times gravity. Okay, are we together up to that point,
Yes,
Kevin?
sir.
Okay, thank you very much, Mr. Daniel. Now, going forward, uh, then we are going to define what is work. Now, work is the weight of water that has been lifted by the pump to a given height. That is Hs plus Hd, which is the suction head and the delivery head, as you can see. Now, from this equation, then we are going to define work by multiplying the weight, which is given here, which is the gravity times the density times the volume, okay? Multiply now by the distance that the water has been lifted, which is Hs plus Hd. If you come back to our diagram here, Hs is this distance up to this point, and Hd is the delivery head, which is this distance up to the distance where the water is being delivered. Okay? Now, let us now define power. Power can be defined as the rate of doing work. Okay? So, for example, if you are carrying water from the ground floor to first floor and you take 10 minutes, then another person takes 1 hour. Who has got more power, Mr. Elisha? Daniel? Wangila? Wangila, can you give us the response? Kevin? Hello? Kevin, can you listen?
Pardon,
Yeah, the question is, if one person, yeah,
pardon me, sir.
okay, I'm asking,
Yeah,
between two people who are carrying
yeah,
water to a given floor,
yeah,
one carries the water from a ground floor to first floor using 10 minutes,
yeah,
and the other one uses 1 hour.
yeah.
Who has got more power, the one with the 10 minutes or the one with the 1 hour? Yes, Kiliswa, can you help your friend?
The
The one
one
with 10 minutes.
who carries the water in 10 minutes.
Yes, because he does that work in a very small period of work of time. So power is defined by the rate of doing work, and that is why from this equation we are going to multiply work multiply by the rate that the work is being done, which is n over 60. So we get power in seconds. Okay, and our final equation is going to be given as power is density times gravity times the bow or the stroke length multiplied by the revolution or rotation of the piston pump, and then you multiply by the area over 240 by the suction and discharge height. So thank you very much. So to summarize this class, I would like to ask you which parts of a piston pump have you learned today? Yes, Ernest, Elisha?
We have learned about the single acting uh, reciprocating pump.
Well, and what are the parts that you have learned today?
we have the piston,
Okay.
the inlet valve, the
Yes.
delivery pipe,
Okay.
the suction stroke, the rod, and the delivery pipe.
Okay. So now for your reference, I'm going to share you a screen where we are going to get a reference for these notes. Okay. And this is the reference. And also for your assignment, we are going now to look at the power equation developed by a double acting piston pump. Okay, so I'd like to welcome in questions at this juncture. Ernest, I can see you have raised your hand.
I have understood.
Well, thank you very much. So, Kiliswa, Daniel,
When are we submitting the assignment?
in our next lesson. Thank you for that clarification. Well, if there are no other any other question, we can end our session at that juncture. Thank you very much.